In the first part of this question, we have to differentiate the given equation with respect to time. So we have recopied the equation right here, and before we differentiate it with respect to time, it's a good idea to take any variable that's underneath a square root, such as the square root of h right here, and rewrite it using exponential notation. So for instance, the square root of h can be rewritten as h to the power of 1/2. And that's going to make computing the derivative just a little bit easier. And here's the rest of the equation. We won't need to rewrite the square root of 20. We will see why that is in just a moment. So it only pertains to the variable. Now, we are differentiating the equation, and it says with respect to time. So this is very important. We will differentiate each of the 3 terms in this equation, actually each of the 4 terms, because the 0 should be taken into consideration. Let's begin with the first term. So to do this, we're going to use a power rule. We multiply the power by this coefficient. So 2 multiplied by 1/2 gives us just 1. Then we have our variable h. We subtract 1 from the previous exponent, so 1/2 minus 1 is negative 1/2. But because we're differentiating with respect to time, we must make sure we multiply by the derivative of our variable h with respect to time. So in other words, multiply by dh dt. Very important. Next, we encounter the second term. Now here we have a constant in front of a variable raised to the power of 1. You probably remember in that situation when you do the derivative, you would just retain the constant. So this becomes 1/45. And then the derivative of t would just be 1, but we're differentiating with respect to time, so you would multiply that by the derivative of time with respect to time, which is dt dt. Now, of course, dt over dt cancels because you're basically dividing dt by dt. That equals 1, so you don't even have to actually include that there. This is just going to be 1/45 overall for that derivative. Then we encounter the 2 radical 20. Now we'll notice that this is a constant, and the derivative of a constant is simply 0. So we don't have to worry too much about that term. The other side, we have 0. That's a constant as well, so the derivative is still 0 there. Now we may wish to clean this up just a little bit. So we have h to the power of negative 1/2 multiplied by dh dt. And then we just have plus 1/45 equals 0. Our goal is to solve for dh dt, recall, so we may wish to next subtract the 1/45 from both sides so that it cancels out on the left. Now we have the left side with our dh dt there, and then this is now equal to negative 1/45. Now there's a nice little trick, I suppose, or a little maneuver here we can use to solve for dh dt. We can actually multiply both sides of the equation by h to the positive 1/2. Let's explain why that's going to work nicely. When you multiply h to the positive half by h to the negative half, you get h to the 0 because you have to add these exponents together. But h to the 0, just like any number to the 0, is just 1. So this basically cancels out, becomes a 1. We are left with dh dt. Over on the other side, we make sure that we multiply the numerators together. So basically, this numerator of 1 multiplies by this numerator of h to the half. This gives us h to the half. Then we multiply the denominators. Now here you have a 45. The denominator over here is just a 1. If you want to imagine, we can even write it in there. This is really over 1. So when you multiply the denominators there, you're going to get 45. Don't forget, please, the negative sign that's in front, and that would be the answer. That is dh dt. For those who wish to rewrite this back in radical notation, you can write it as negative square root of h over 45. And that does look perhaps a little tidier. This is the correct answer to the first part of the question. We go to the second part of the question, and it asks us how fast in feet per second was the height of the water decreasing. So notice we are trying to figure out a rate here because they're asking us how fast was the height decreasing. So that is a rate. It's a rate of change. And in fact, it is the rate of change in the height with respect to time. In other words, it is dh dt that they're asking us when the height is 4 feet. So what we're going to do is take our equation for dh dt, which again is the rate of change in the height. It's basically how fast the height of this fluid was changing at a given point in time. And we're going to plug in the given height. Now the given height was 4 feet. Indeed it was. So we'll put in a 4 right there. And then this divides by 45. Nice and easy simplification. The square root of 4, of course, is just 2. So you end up with negative 2 over 45. And the unit here, as indicated by the question, was feet per second. Now just be a little bit careful, because if you're typing this into a homework system such as WebAssign, it's asking you how fast is the water decreasing. The word decreasing already tells us that the rate is negative. So I would not include the negative sign in the final answer. I would just say that it is decreasing by 2 over 45 feet per second. And that would be the correct answer to the second part of the question. Thanks for taking the time to watch this video. If you're interested in making a small donation to my cause, I would greatly appreciate it, but of course, please do not feel obligated to do so.